it's not a very well done PowerPoint. So I figured I'd give you the copies of this. So when we talk about fibers, what we're really getting at is we're looking at things that are longer than they are wide. But they're used as a building block for making other things. So think about a hair. Would a hair be classified as a fiber then? Is a hair longer than it is wide? Yeah, a hair is classified as a fiber. So we kind of did this backwards. We should have started with fibers, then talk about hairs, but oh well, we'll get over it. So all these fibers, they can either be man-made or they can be grown in nature or grown on a farm if you don't want to consider that to be nature, which you shouldn't. All right, what are some examples of fibers that you guys are already aware of? Nate, Bryce, you guys gonna be all right? I'm calling you out on a video, so this is recorded forever now that I'm calling you guys out in class. You all right? All right. All right, yarn and string. Yarn is when you take a bunch of fibers and combine them together to be able to make something that has more strength but the desired properties that you want. But then in order to do anything with the yarn, you got to take the yarn and weave it together, right? To be able to make whatever fabric it is you want to make. What are some examples of individual fibers, though? Or things that they might come from? Muscle fibers. Those are protein-based fibers. And so it's a group of proteins held together, but is a muscle made up of just one fiber? No, it's a bunch of them combined together. Thousands, if not millions of them bound together for doing that purpose, right? Same thing can be thought of with the fibers that we use for making your clothing. What are some of the things your clothing are made out of? Cotton's a great example of a fiber. You ever see the stuff that comes out of a cotton plant? You ever see the really thin strings that come out of it? And then in a factory, they take all those little strings and somehow turn them into that pretty cool shirt that you're wearing right now. Don't they? Because most of you are wearing cotton shirts looking around because I see a lot of people in t-shirts and sweatshirts today. Kind of weird to think about that little stringy thing all of a sudden became that. What are some other examples of fibers? Polyester is a great example of a synthetic fiber, and polyester is quickly becoming the most common fiber that's used in the textile industry. Where does that come from? Any ideas? Yeah, where's polyester come from? Well, I guess let me rephrase the question. Is it man-made or is it grown? It's man-made. So so now we know it's man-made, so it's not going to come from any other type of organism. Where does it come from? Where do we get the stuff for making polyester? No ideas? How'd you guys get to school today? You guys rode in some sort of vehicle to get here unless you walked, right? What do those vehicles run on? Where's the gas come from? From the gas station. Where's the gas station get it from? All right. Come on, work with me, guys. It all comes out of the ground, right? What do we call the stuff we pull out of the ground that we then process to be able to make into gasoline and kerosene and what do we call it's a type of oil, yes, but that's a little bit more specific name to it. It's not so refined. When somebody's not a refined person, we say they're crude, don't we? Crude oil. You guys, here's the thing. That stuff that crude oil it's separated out to be able to make the gasoline and all the stuff that you're putting in your vehicles and to put the asphalt on the roads. You know what? Some of that stuff, when it gets separated out, is then used for making plastics. Polyester is nothing more than a plastic. So congratulations. Many of you are wearing plastic right now. That's kind of weird to think about, isn't it? It matters the type of clothing. That's a good good comment there. When you burn these synthetic fibers, what's going to happen is it's going to melt, kind of like when you burn plastic. You know how when you burn plastic, it kind of starts to bubble a little bit and then it melts and it runs. When you burn something that's cotton-based, that doesn't happen. It just lights on fire and boom, you have ash. So that's one of the ways we can determine whether the fiber is a synthetic fiber or a man-made fiber. Or excuse me, that's the same thing. A synthetic fiber or a natural fiber is by burning it. When it burns, based upon the pattern of how it burns, based upon the smell when it burns, based upon the type of ash that it makes, based upon the color of the flame when you burn it. We can look at all these things to help us determine the origin of that fiber. All right, well, we can't just take one little individual fiber and make something. We got to take thousands and millions of them and combine them together in some way. And that's what all your factories do. They have all the weaving presses to be able to put together. So you take the fibers, you combine the fibers into a yarn. You then take the yarn, combine them together to make some sort of fabric. You then take the fabric and combine it together in some way to be able to make whatever product it is that you're trying to make out of that particular fiber. All right? Now, when we look at this, one of the things that we should be familiar with is the difference between warp and weft. Because when they take these fibers and combine them together, they need to weave them in and out in order to be able to give it structure. The weave is going to help to determine how sturdy it is or how flexible it is. You weave it really tightly, it's not going to have as much flexibility, but it's going to be a stronger material than when you weave it more loosely. All right, well, when we look at this, the warp is going to be the pattern as you work along the length of that particular fiber or fabric, whichever it is you're working with. The weft is the weaving pattern as you go across the width. So warp goes with length, weft goes with width. All right, and so just to kind of wrap up the little conversation there, yarns are when you take a bunch of fibers, combine them together into one. Warp is your lengthwise pattern when you look at the fiber and how it's combined together. The weft is the widthwise pattern. And then oftentimes we blend more than one fabric together. If you look on many of your tags on your clothes, are they all 100% cotton? In some cases, yeah. But anybody get the pre-shrunk stuff? They say, oh, it's pre-shrunk or shrink resistant. You guys don't buy your own clothes? I don't either. When you look at the tags, they'll often say pre-shrunk, or they're going to say shrink resistant. Like all my shirts, all my dress shirts that I wear are wrinkle resistant because I hate ironing. And what they'll often do is they blend more than one fabric together. And what that'll do, and it's usually your naturally occurring fibers that are more likely to cause the shrinkage. So your cottons, primarily cotton. Cotton will shrink after repeated washes in hot water. So what they do is they mix in a little bit of a synthetic. Often it'll be an acrylic or it'll be polyester. Just a little bit, maybe a 99 to 1% blend. And what that 1% blend does then is make it so that the cotton has nowhere to shrink to. The synthetic fiber helps to hold everything in place so the cotton doesn't shrink up on itself. Most of the wrinkle-free stuff that you buy is a 50-50 blend of cotton and polyester. All right, so if we keep with this, some other things we're going to look for, we're going to look at the dyes. Each different clothing manufacturer uses different dyes to help determine the colors of the clothing that it is that you guys are buying off the shelf. So Tommy's blue shirt and Hallis's blue shirt, if we assume they actually were the same blue, even though I realize they're not, I'm not that colorblind. If we assume they were the same color, if they came from different manufacturers, it may not be the same dye that's being used to make that same royal blue. And so what we can do is we can do analysis of the dyes, and that can help us to determine the manufacturer from which that fiber came from. Because each manufacturer uses a different dye. What they use is a process called chromatography. See the little strip that I have over hanging on the board? It has the little blue speck. And if you look closely, there's a yellow speck. It's to the right of the smart board there. See what I'm talking about? When you look at that, can you see the yellow? Let me turn the light on a second. What I did was took a Sharpie and I put a little mark on that little piece of paper. and then I dip the paper into some sort of solvent, something that'll dissolve stuff. And I don't remember if I used water. I had to have used most likely ethyl alcohol for that one. So ethanol. You guys have heard of ethanol, right? And it's mixed in with your gasoline. I used ethanol on that one. And what happens when you take a paper towel and you dip it into water, but you keep holding the paper towel? So let's say you have a pool of water sitting on the countertop. You dip the paper towel into that little thing of water. What happens to the water travels up into the paper towel, doesn't it? Even if you don't put the paper towel directly, the entire paper towel directly into that puddle on the counter, it still draws up, doesn't it? That's called capillary action. When you do chromatography, you're taking advantage of capillary action. And so you dip that in there, and then the solvent's going to run up that paper. And that it's not really that fancy of a paper. I think that one I did with a coffee filter. So it doesn't have to be a fancy paper. So then what happens is the different components that make up that particular marker separate out. And so the fact that I got yellow and blue to separate out on that particular piece of paper there, what does that tell you about the color of the marker that I made the dot with? If I got blue and yellow. Say that louder. It's green. Because isn't green, blue, and yellow combined? So I did that with a green Sharpie. Well, we could do the same thing with the dye that's in fibers. And we can run the little chromatography thing. And there's little measurements you can do with it called RF values. You go through and you measure those, and based upon the RF values that you get, you can match it up with a particular dye that was used by a particular manufacturer. Mr. Landry. Sure. Okay, yeah, no problem. You're welcome. So any questions with that? If we get time, hopefully we'll get a chance to do some chromatography ourselves. So then we've already talked about how things get transferred. So you can get transfers from direct transfers, so the suspect coming in direct contact or the victim coming in direct contact with that particular evidence, or we have secondary transfers where there's a third party involved. So it transfers from the suspect or victim to something else, and then it gets transferred to a third thing. All right, so in forensic science, what we'll often do is we use a lot of classification charts. All right, so if you look at this, this is just a way of taking, okay, we have a fiber. All right, so if we have a fiber, what can we do with the fiber? Well, we can take the fiber and classify it as either coming from something natural or coming from something that we make in the lab. All right, so now that we know, okay, we have these things that can be naturally produced. Well, the things that can be naturally produced can then be broken down into three categories. They can come from animals, they can come from vegetables, or they can come from minerals. Well, all the animal ones, there's really two. There's ones that come from hair. There's ones that come from silk. See how this works? And I can work my way down this. My man-made fibers can be classified as inorganic or organic. The organic ones can come from synthetic polymers, which means they're made in the lab, and those include these ones. And if you look closely, these are all plastics. Or they can come from naturally occurring polymers, and these are examples of that. But I can also go backwards. I can say, okay, I have rayon. What can I tell you about rayon? Well, what I can tell you based upon this classification chart is that it is made from natural polymers that are organic. What does it mean to be organic? Composed of what element? If it's organic. Oh, we got a lot of bio kids in here, you guys. You guys talk about this in biochemistry. I'm telling you, your biology stuff you did is never going to go away. The biochem one? Organic chemistry is the study of one particular element and how it interacts with other things. And it's the main element of life. It's carbon. Good call. So when we see organic, that means carbon is primarily composed of carbon, or carbon's the main backbone for the product. So I can use this to go backwards. But here's the thing. In forensic science, not only do we have these classification charts, we also have charts that show us, okay, we found this fiber. What do we do to test it to see if it's naturally occurring or if it's a man-made fiber? And the first test we do is we look at it under a microscope. You can clearly determine by looking under the microscope whether it's a naturally occurring fiber or one that was made in a laboratory somewhere. And I'll show you examples of that here in just a few minutes. All right, and then, okay, we've determined this is a naturally occurring. There are tests then we can do to determine whether it came from an animal, whether it came from a vegetable, or whether it came from a mineral. So then we do that test, and it says, oh, it came from an animal. Okay, well, now there's a test to see if it's a hair or if it's a silk. So now we have these testing charts alongside these classification charts so that we can perform these tests, and based on the results of these tests, it helps us to determine the exact fiber that it is that we're working with. That's going to be the big thing you're going to be doing in the lab. When you guys go into the lab, I'm going to give you a couple of classification charts. I'm going to give you a set of tests to go with those classification charts. And you're going to complete the test, and based upon the results of the test, it's going to help you to determine, hey, because it passed this test, it didn't pass this test, and then it had this result here for this test, that tells me right there that this has to be polyester. So that's the way a forensic scientist would be working with that particular fiber. All right? Questions there? Alexis, you're wanted in the office a second. You're wanted in the office a second. Okay. So some examples. Some naturally occurring cotton. You guys already brought that one up. Wool, I heard come up. Somebody brought up sheep. You know, hair. And look at the microscopic images. Is the cotton here nice and neat and uniform? You know, is it the same width throughout? No. Does it have the same coloration throughout? No. Yes, there's not much order to naturally occurring fibers. How can we determine that this is actually a hair? Yeah, look at the medulla running through the middle of it. If you look closely on this one, you can see medulla. If you look closely even on the green one, even the colorblind guy up here can see the medulla here on the green one when you look closely. But then we also talk about sometimes we get blends. Check this out. What we're looking at here is you have the fiber. It's been cut down. Maybe you took a pair of scissors and you cut it. And then you looked at the ends of where it got cut. And if we look closely, look at the little red pieces. Aren't those all nice and neat and about the same size and shape and width for the most part? Can you see that? And then look at these other ones, these little circular ones. Are those all uniform and nice and neat and same width? And no. So when I look at this, this tells me I have a blend here of a synthetic fiber with a naturally occurring fiber. And the naturally occurring fiber is probably the green, and the synthetic is the red. Does that make sense? So some of the man-made fibers out there, we have rayon and nylon. Those are the two most common. We've been making those for about 100 years. So synthetic fibers have been getting made for about 100 years. The thing with synthetic fibers, though, is because they're getting mixed together in a lab and they're getting worked on in the lab, they make this big vat of it, and then what they do is they shoot it out into these little forms. Well, when they shoot it out in these little forms, can they control the exact diameter and the exact length and the exact width and control all of those factors? And when they have forms, you can do that, you guys. If you have something to pour that into, the form's going to make it so they all have the same shape, size, so on and so forth. Think about all the toys that you guys bought, all the different Buzz Lightyears that were sold over the last 15 years. If everybody got the same model, don't they all look the same? Because in that factory, they have a form that makes it so that when they make the wings for Buzz, they all have the exact same shape, width, length, depth. It's the same thing when we're mixing fibers up in a lab. We can make it so they all have the exact same appearance. And then fibers can either come from natural or synthetic polymers. What's a polymer? So polymers the same as the whole thing. And so then monomers would be individual piece. Good job, Ethan. Yes. Think about it like a puzzle. When you take the when you first pour all the puzzle pieces out, it looks like nothing, doesn't it? Just a bunch of little random scattered individual pieces, doesn't it? And after hours upon hours upon hours, unless you're still working on the 25-piece little kids puzzles, maybe then it's only down to minutes. But when you put those together, you get this beautiful picture once you put them all together, don't you? Well, the beautiful picture of all those individual pieces combined together, that's a polymer. All the little pieces that are used to make that up are called a monomer. So the fibers, when we're working with them, those are the monomers, and we combine those all together to be able to make this other product that is composed of little individual pieces of that particular fiber. Well, sometimes these little pieces are coming from naturally occurring stuff. Other times, you get to think of the mad chemist that's in the lab with the geeky glasses and the lab coat, and they're mixing things all together. Some of the stuff that you guys are wearing was made in that way. So to make my point, which one is the naturally occurring fiber and which one is the synthetic fiber? Palmer, what are you thinking? And so the synthetic's the one on the right. Why do you say that? So the fact that it's nice and neat, uniform. Even look at the coloration. Isn't the coloring and the distribution of the pigments inside that fiber the same throughout on the synthetic one there on the right? Is it that way with the naturally occurring ones on the left? Yeah, we can't get the dye to be exactly uniform in the naturally occurring ones. Now, when you wear a cotton shirt, does it look all the same? It does, but if you look at it microscopically, you're going to see little pockets where the colors are a little bit darker, and then you're going to see pockets where the colors are a little bit lighter. But the overall scheme, when you look at it with your normal eyes, it all looks pretty uniform, even though in reality, it's not. Good job with that, Palmer. So then, last topic, and then we'll move into the video. When we talk about fibers, when we talk about synthetic fibers, so the ones that we actually make in the lab, sometimes the stuff for making it is made naturally. Other times, it's the mad chemist. The ones that are made from naturally occurring stuff, but we change them and make them better and then put them back together, we call those regenerated fibers. It's made from cellulose, so os. Going back to bio. Have you figured out I'm a biology geek? Love my biology. Os, what does os mean? What does that tell you about the molecule? It ends in OSE. What type of molecule is it? Somebody said you guys just took the test on that. So I'll make a multiple choice. How's that? Is it a protein? Is it a carbohydrate? Is it a nucleic acid? Or is it a lipid? I hear 1 vote carb. So Ethan's picking you all up, putting them on his back. You guys gonna ride along? He's right. It's a sugar. So wait a minute. Some of the stuff you're wearing is made up of sugars? That's kind of weird, isn't it? But it's not the same kind of sugar as what we think about what you put on your Cheerios. All right, rayon, acetate, triacetate. You guys know some of the if you wear sweatpants or anything that has the elastic waistband, what do you think the elastic is made out of? It's a particular synthetic fiber. And in this case, most of the time it's acetate. So we have an idea it probably did come from plant sugars. All right, synthetic ones, these are ones where they say, okay, the formula for making this is you got to mix this much from the lab. Okay, pull it off the lab shelf. I need this much from here. I need this much from over there. Mix them all together. Now I got this cool thing I can turn into a fiber. So it's all stuff taken off from the shelf. Good examples of that are nylon, polyester, and your acrylics. All right, so any questions on the differences between those? I think that's far enough for today. We'll call it good there. And then we'll move into the how we test this forensically next time that we meet. All right, no questions then?